In this new photo taken by the Hubble Space Telescope, we see an interesting structure that we have not seen before. You can compare roughly how big this giant line, which occupies a significant part of the photo, is by looking at the sizes of other galaxies that we see nearby. The line looks almost even larger than the diameter of a galaxy. Of course, this is the kind of situation that astronomers would not expect to see in photos either. Therefore, astronomers initially thought that this structure, which they did not expect to see, was an image error caused by the reflection of lights on camera detectors. However, when the image errors on the photo were analyzed and cleared, this structure still stood as it was in the photo. So we're talking about a strange thing that, despite being as big as galaxies, does not resemble any galaxy or identifiable celestial body in any way, in the sense that we know, if there are no errors in the photo, that is, if this formation is real, the best way to figure out what it is to make spectroscopic observations. In other words, we are talking about analyzing the electromagnetic radiation coming from this region, so when we examine the wavelength of light coming from the structure here, we can get more precise ideas about what is present in the structure. Astronomers conducted a spectroscopic analysis of the structure using the KEK Observatory in Hawaii to understand what this structure was. As a result of observations, it turned out that this structure, which is 200,000 light-years long, consists of young and blue stars. So this structure was filled with stars that were hot and very bright. So how can such a huge structure consisting of young and hot stars get such an interesting shape in intergalactic space? Although it may sound quite ironic at first, the most likely reason for this is the presence of a supermassive black hole moving at very high speeds here. But until now, we have always known black holes as objects that wipe out and destroy everything around them. How can a black hole cause the formation of new stars? Or we can claim that the reason for this photo is actually what kind of black hole it is. In other words, the fact that we always see black holes as objects that destroy everything around us is a relatively erroneous perception that has been settled in our minds due to popular science documentaries or science fiction movies. Of course, an object that has the misfortune to fall into a black event horizon has no chance of getting out of there. We agree on this. But because of the perception of monster black holes in our minds, we often forget that there are celestial bodies that affect the interstellar space around these bodies, and we know that in order for stars to form, plenty of gas must be trapped under appropriate temperatures. For example, the jets emitted from the two supermassive black holes, which we discussed in detail in our previous video, led to the compression of gas clouds in the galaxy, making these regions ideal for star formation, in contrast to destroying stars. The new discovery basically involves a similar mechanism, because we know that there are giant halos covered with gas and dust that surround galaxies in a spherical way. Of course, if the substances in these galactic halos are not as dense as in the inner parts of galaxies, they can form new stars under favorable conditions. In other words, even though we know that the intergalactic medium is mostly empty, for example, it is possible for a jet of black holes to form new stars by decaying matter in a certain region. But what creates the structure in the photo we are talking about is not exactly that a jet of black holes creates new regions of star formation. Because the line formed by these stars is also not inside any galaxy. It is seen in interstellar space. There is a much more interesting situation here. This time a single supermassive black hole comes into play, as well as other black holes. So here we are talking about a very violent and gigantic cosmic event as a result of the merger of both galaxies and supermassive black holes. This galaxy that we see just above the giant line in the Hubble photo was formed as a result of the merger of two galaxies about 50 million years ago. We can determine that such a merger happened in the past by looking at the shape and core structure of the galaxy. There is at least one supermassive black hole at the center of a significant part of the galaxies in the universe. Therefore, the merger of these galaxies 50 million years ago also means that they began to revolve around each other at the center of the new galaxy, which formed in the black holes located in both galaxies. In other words, we are talking about two supermassive black holes orbiting each other. In astronomy we call such celestial objects binary, that is, binary black holes. The rotation of the two black holes in orbits close to each other also makes it inevitable that high energies will occur on an inconceivable scale. So much so that as binary black holes rotate around each other, they begin to ripple the fabric of the universe, that is, space-time, almost like a sheet. The resulting energy is so high that the center point of the gravitational waves caused by these black holes can also be detected by the Earth, even though it is billions of light-years away. If you remember, a point in 2015 years was observed by gravitational waves created by two black holes merging 3 billion light-years away. So what if there is a third supermassive black hole in the system during such a strong merger? Although binary black holes are common, the merger of three black holes is a very rare event in the universe. Although we do not know exactly what the result of such a merger will be, the energy of the two black holes merging can be transferred to the third black hole, which can lead to the ejection of this black hole out of the system. Because the third black hole and these three black holes, which are later included in the system, continue to rotate around each other in a chaotic and unstable way and emit high energies. But of course this will not last forever. One of the most likely scenarios to happen in such a situation is that one of the holes steals the momentum of the other two black holes and hurtles out of the galaxy with this momentum. So we call them runaway blacks, and the existence of runaway supermassive black holes has been theorized many times on paper until now. For example, we know that there is a supermassive black hole at the center of our galaxy equal to 4.3 million solar masses. Of course this is, although this may seem like a very high mass, gigantic object to us at first glance, it is actually a black hole that remains quite small compared to the mass of the Milky Way galaxy. Therefore, like many other galaxies, our galaxy may have lost its black hole, which had a much higher mass in the past, as a result of a merger. But besides these ideas, we also did not have any observational and meaningful evidence of the existence of runaway supermassive black holes until now. This photo he took offers both an observational and consistent image of the outcome of the gravitational battle of the three black islands. Because in the photo, we are observing the effect created by a galaxy that merged millions of years ago and an invisible body, despite the mass of 20 million suns, that was thrown hundreds of thousands of light-years away from this galaxy. A body with a mass of 20 million suns, but invisible. It can only be a supermassive black hole. Moreover, the tremendous speed that this object has, depending on the effect it creates, is also interesting. To better understand the scale of this cosmic merger, it is also worth remembering the decoupling between the types of black holes. Black holes are also classified in different ways according to their mass. For example, stellate mass, that is, black holes that we call stellar black holes, are formed as a result of the collapse of a star into itself, and their mass can vary from 5 solar masses to tens of solar masses. Since such black holes are relatively larger and easier to form, we know that there must be more than 100 million stellar black holes, for example, even in our galaxy, the Milky Way alone. But on the other hand, black holes that we call supermassive are black holes that are so big that they can be billions of solar masses, and their number is naturally rarer. For example, although we say that there are more than 100 million starry black holes in our galaxy, this number drops to 2 when it comes to supermassive black holes. So in the event in this photo, we are not talking about a large number of but relatively low-mass stellar black holes in the universe, but about 3 supermassive black holes orbiting each other, whose masses can be equal to millions or even billions of solar masses. Then he would not be surprised that a black hole that decays out of the system is a result of cosmic chaos big enough to survive even the gravitational influence of a galaxy is very fast. As a matter of fact, this black hole moves fast enough to travel the distance between the Earth and the Moon in intergalactic space in just 14 minutes. A black hole moves fast enough to travel the distance between the Earth and the Moon in just 14 minutes. Of course, we specify the distance between the Earth and the Moon only in order to better visualize how fast the black hole is decaying in our mind. So let's also note that at this point we have no connection to this black hole and there is no reason to worry. Already at the very beginning, because this black hole is so far away from us, we can understand that the event we are observing here actually happened when the universe was only half its current age. So, how can new stars be formed here? We have said that this black hole has a mass of 20 million suns, and there are halos of gases around galaxies. As such a black hole moves at supersonic speeds, it interacts with the gas clouds and ionized hydrogen surrounding galaxies, allowing a line of species to form behind it. These shocked gas clouds left behind by the black hole cool down quickly, making these regions suitable for new star formation. As a matter of fact, the linear structure of the structure visible in the photo and spectroscopic typical analyses really indicate the existence of a supermassive black hole. So this photo may be the first observational evidence of a supermassive black hole escaping from a galaxy. Although the observations and theories seem to overlap with each other so far, of course, in the future telescopes such as James and the Space Telescope will try to obtain and confirm more data about this black hole. But if this is true, the results of this observation from an astronomical point of view are as follows. We understand that runaway supermassive black holes may be much more numerous in the universe. This observation also shows us that we need to observe recently merged galaxies in order to find more runaway black holes. All this indicates that the supermassive black hole hypothesis, once thought to have escaped from the Milky Way galaxy, may also be valid. In addition to all this, it is also worth recalling finally that this observation alerted NASA on social media. It was also marketed with titles such as Invisible and Monster Black Hole Discovered. In fact, such deceptive and panic-creating titles are formed as a result of transferring content from foreign sources by making one-to-one translations. Because the contents have been translated by people who do not master the terminology of astronomy, it is inevitable that such errors will occur when translated. While explaining astronomy in a way that everyone can understand, on the one hand, we strive not to compromise on science. If you also want to contribute to our work, you can provide financial support to us by clicking Join YouTube or Thank You button. So goodbye, see you in a completely different corner of the universe in the next video.